What's going on, everybody? Welcome to CS540 midterm review. Since I saw some questions on Piazza about the midterm questions, so I just pick 2017 midterm and do a brief explanation. So the first question, the traffic lights have three colors: green, yellow, and red, and also their time. So it asks if a driver saw a yellow at the random moment, what is the probability the next second will become red? So here we have a 4 yellow, and we also have a 4 red here. So the probability that we saw, the only thing that can happen is at the very last second of yellow light, then it will jump to the red, and it's already given the condition that the driver saw the yellow light, so which is this 4, and one of them is just 1/4. So the answer is C here. The second question, I think it's pretty simple to fully specify how many numbers are needed. So A has 4 terms, B has 3 terms, and here B can only choose 2 of them since it has to leave 1, and that is 4 times 2, and which equals to 8. Third question, so it's again initialized as 0, 0. Then each player can just flip 1 or 2 bits at the same time. So for example, from 0, 0 to 0, 1, and it has to give the other player $2. Sorry, $1 for each move. So for example, from 0, 0 to 0, 1, you have to pay $1. From 0, 0 to double 1, then you have to pay $2. So the player who achieves the 11 will win and will collect $10 from the other player. So of course, so it asks the game theoretic value for the first player. So the game theoretic value is the 2 players will always play optimistically. So of course, at the first time, the player will just flip 2 of this coin to double 1, and it will give $2 to the another player. And then another player, since he loses, he will pay $10 back to the first player. So which is the first player collect $10 and pay $2, which is $5, which is 8. Fourth question is the stack space. What's the stack space that is sufficient to DFS? So here is a very basic tree here. So our goal node is here. So if by the algorithm, it will be like A, C, B. So first I get these 2, the 2 children of A, and I DQ B, and in order to get D and E here, and so on and so forth, and just DQ E, which will goes to other children here. So actually, you can see that every time we will DQ one node, and we are going to add all its children. So suppose there is the maximum length is D, and the worst case that our goal node is at the very last branch here. So we're going to have a D here, and we just times K minus 1. Since every time we have K children, yes, we append K items in our stack. However, we are going to DQ1 from that. So the maximum length will be DK here. The fifth question, the advantage of iterative deep link search compared to DFS. So the difference between ID and DFS is iterative deep link search actually has the advantage of both BFS and DFS. So first of all, it will find a better goal, which is absolutely true, since DFS here may not find a goal if it's, for example, infinite, may need less space. That's also true, since, for example, just now the case is at very in the middle actually, and the next branch, so it will going to find at very deep with a lot of space if I just use DFS. However, use iterative deep link search, it will set the maximum depth every time, so that will save time, and also terminate earlier, which is D, all of them. The fourth question, so you get the probability of get a headache is 1 over 10. To get a bird flu is 1 over 1,000. So, and also the probability that you got a bird flu and the probability that you have a bird flu and to get a headache is 1/2. And what's the probability that you have a bird flu, which is and the probability you have a headache? So headache is 1 and bird flu here is 1. So just remember, so here actually 0 b equals to 1 plus, so this is actually 1. So it's just the sigmoid function here, some sign function here. So we can just calculate this term by using 1 minus this term, which is 1 minus half equals to half. The seventh question, so the phrase, given the phrase San Francisco appeared m times, and also there are n words tokens, what's the probability of frequency that by given the word San, the next word is Francisco? P, and Francisco divide by giving the probability of San, the next word is Francisco, is actually so if we don't divide by n, that is actually how many times that Francisco appeared divided by how many times Cisco appeared. So the probability is actually this term divided by the n here, but I just cancel the n in denominator and numerator together. So we know this term, that is m. However, we don't know how many times the San appear in the sentence. So the answer is E, none of the above, as we don't have enough condition. So eighth question, so one actually is asking, one is this term. So when I equals to 1, then it's minus 1, the value of this. If I equals to 2, then it's half, I equals to 3, minus third, I equals to 4, and 1 over a quarter. So since it's asking if one runs the hill climbing algorithm, so hill climbing algorithm is actually use the greedy search method. So it will just search the best value at each time. So if it is at 1, the only neighbor is 1/2 here, so it will just go to 1/2. If I equals to 2, then the same case. If I equals to 3, you will compare the value to half, fourth. So since half is the largest, so it will go left to 2, and which will reach the global maximum value. However, if it's at 4, it will compare the value between the minus third and also minus 1/5, since minus 1/5 is larger than minus 1/3, so it will just goes to 5 here, and it will never goes to 2 again, which is the global maximum value. Instead, it will just reaches the local maximum value. So that is 1, 2, and 3, and how many initial states? So there are 3 can reach the global maximum value here, which is D here. Ninth question, which of the following is possible? So if for first one, if A and B are independent and the possibility of A and B are equal, then these two terms will equal to each other. Since if P A and B are independent to each other, PA condition B is actually equals to PA, and if PA equals to PB, then this equation always satisfy. And here, if event B is always true, then PA it just equals to PAB. Third, if both A and B are just is not possible event, then the left term and right term are both equals to 0. The 10th question, however, I think the answer is a little bit strange. I think the answer is E. They all can be admissible under some circumstances. It's just my own opinion. So in the exam, I will choose E instead. 11th question, so the probability is this term when T is temperature. So the possibility of this term will goes to next term. So the probability that we stay at S instead of moving, we just use 1 minus this term, which is D. Yeah. So question 12, which node will be pruned? A is minus infinity and infinity. B's value, so this is the alpha beta value here. B's value we don't know, so it moves to B. And since the max move play first, so the first is max, the second line, which is B, and C here is min. So B here will perform min value. Min between these three is 2, so it will change the beta to 2 back to A here. So from B back to A here, and we're going to change the value. Since A here is the maximum maximize algorithm, so here it will just change alpha. Since 2 is larger than minus infinity, and here compare both alpha beta. Alpha is smaller than beta, so you just keep moving. We don't know C's value yet. So first it will goes from C to 4. So here is the minimize algorithm. So we will compare 4 and infinity. Since 4 is smaller than infinity, so it will change the beta value from infinity to 4. Next, it will compare 1 and 4. 1 is smaller than 4, so it will change 4 to 1. However, at this stage, we found that alpha beta is actually larger than beta value. So here, all the terms after C will just get pruned. So the answer would be 7 get pruned, which is C here. The 4th question is a little bit tricky. So it's actually asking which order of gold check is impossible with BFS. So the next condition is really important without specifying the order of successors when putting them in the queue. So for example, it can either from the queue can either first of course is A, the next could be B, C, or CB. So that is stuff. So here there are some things. Since at the beginning we will have the A in our queue, if for example we just put the left first, then it is A, B, C, then B's children is D, E, F, and C's children is G, H, I. So and of course we can also have, for example, C, B, then C's children is G, H, I, and B's children is D, E, F, etc. So whatever you perform this kind of algorithm, the root node, which is A, will always at the first beginning. So A can never be happened under whatsoever circumstances. But for example, if B before G, which is this case, it is possible, and I before D, which is this case, it is possible. So only the first choice is not possible. So I think this is the end for the midterm review. If you have any questions, concerns, please feel free to leave comments below. I wish all my best to our next week's midterm, and have a nice weekend.